So I think we will stop here. So this one, if I consider, it's a simply supported beam, right? So because you have two supports on the ends, so it is a simply supported. So this is also a cantilever beam. So we can able to see the flight, right? So which is connected. So the wings of the flight is connected to the body, so which will be considered as a fixed support, right? So the other side you have different types of loads, right? So this one is we call it as a propped beam, right? So this is different. So it's a cantilever with a support, okay? Right. Now we will try to solve some problems related to these things. Right. So what type of beam is this? Anyone? What type of beam is this? Where are the supports? At location A and location B. So if your beam is up to B, then I can say it is simply supported. So it is extended, right? So it is a single-sided overhanging beam. It's a overhanging beam. Okay. Right. So now you have two supports. So at A and at B. At A, what type of support? It's a hinge support, right? When you have a hinge support, we know that there will be two reactions, right? So one will be AY, one is AX, another one is AY, right? One is AX, another is AY. You'll have two reactions at this point, okay? So next, if I consider this B, so B is a roller right of support, which means I will have only one reaction, which is BY. Only one reaction, which is BY. Right? I think this different types of supports we discussed in unit 1 itself. Same concept, right? Even though it's a beam, we are following the same concept. So this is your support, right? So now what I can say that, and I say that it is an equilibrium state, which means I can say that sigma fx I can equate it to 0, sigma fy I can equate it to 0, and moment at any point is equal to 0. So where I am going to take moment, where I have maximum unknown force. My maximum unknown force is at A. So I will going to take moment at A and I am going to equate it to 0. Right? These are my equilibrium conditions. You have to follow that equilibrium conditions and you have to solve this. Right? Okay, let me proceed one by one. Let me say that sigma fx is equal to 0. Do you have a horizontal force? Yeah, only one force, Ax. So I can say that Ax is equal to 0. So there's no other force, right? It means that there is no reaction. So this is my first part. So that is over. Okay. Next, let me equate it. Sigma Fy is equal to 0. Sigma Fy is equal to 0. Right? So we will start from A. Slowly we will go. So Ay, you have Ay. So positive Ay. This point you have a moment, so it is not a force, it's a moment. I can't add it, right? You can leave it directly. Next, you have this 8 kilonewton. 8 kilonewton is acting downward, so which means negative. So let me say that -8. We put -8, right? And you can able to see that you have a UDL here. So this UDL is 15 kilonewton per meter for how many meters? 3 meters, right? For this is for 3 meters. Okay. So as I told you, so this one, what I can do, I can consider like this. So this is my UDL, right, which is 15 kilonewton per meter for 3 meters. If I convert this to a point load, you will get something like this. Okay. 15 into 3, W into L is the total load, where it will be acting at the center, which is 1.5. In that case, so what we will get, so that is also downward direction. So I can write it as minus 15 into 3, right, which is 15 W into L, right? So that's it. So there is no other force. So only 1, 2, and 3. So this is equal to 0. I can equate it, right? In that case, sorry. I think I missed one more. I missed one here. So I have by also, right? So this by, right? So by is positive. So plus by is equal to 0. So which means I can write it as ay plus by is equal to, so 53. So 53. So this is my equation 1, right? So this completes this part. Sigma Fy is equal to 0. You add all your vertical forces. So Ay is there, right, which is upward direction, positive. So I have written as Ay. Next, 8 kilonewton downward, so negative, so minus 8. And this is a UDL. So if I consider this UDL, if I convert this to a point load, what you will get? You will get at the center, which is 15 into 3, right? 15 per meter. So ஒரு மீட்டருக்கு 15 கிலோ நியூட்டன். எத்தனை மீட்டருக்கு இருக்கு? 3 meters இருக்கு. So you have to multiply with 3, right? So which means that is also downward. So minus 15 into 3 plus by. By is this one, right? So plus by is equal to 0, right? So I will get something like this. Ay plus by is equal to 53. So that is equation number 1. Now what I am going to do, I am going to take moment at A, and I am going to equate it to 0, right? So I'm going to take moment at this point. Okay, so moment is force into perpendicular distance, right? Perpendicular distance where you are taking moment. From there, what is the distance? At A, this two force doesn't have distance, so it will be 0. Next point, this point, you have already a moment. I should not multiply with this distance because it's already a moment, right? So 20 kilonewton meter. So rotation is, it is rotating in clockwise. So we will put clockwise as negative. So which means minus 20, minus 20, right? Next, 8. So from 8 to A, what is the distance? Totally you are having 3, right? So force into perpendicular distance, 8 into 3. What is the rotation? Again, that is also clockwise. So which means minus 8 into 3, right? Next, this by. Let me go for this by. By, from by to your A, what is the distance from by to your A? So 2 plus 3, so totally 5, right? My distance is 5. In that case, so this by is rotating in anti-clockwise direction. So plus by into 5, right? Any doubt in this up to this?
No, sir.
Yeah. Now this one, this UDL, we are converting this UDL to a point load. So when I convert this UDL to a point load, you know that. So you will have this force here, this point load here, which is 15 into 3, 45 total load. That will be acting at a distance of 1.5, center of 3, right? At the center of 3, which is 1.5. Now, so this is my point load. So this point load from here to A, what is the distance? So 1.5 plus 5, right? It is around 6.5 meter, right? Force into perpendicular distance. The rotation is now clockwise. So minus 45 is my force into perpendicular distance is 6.5, right? This is equal to 0, right? So you can equate it. You can identify what is the value of By. What is the value of By? So you are getting 67.2. Very good. So 67.3 kilonewton. So once I got my By, I can substitute this in equation 1 to identify what is my Ay. Right? What is my Ay? So Ay is equal to 53 minus 67.3. Right? So what is the value?
Minus 14.3.
Minus 14.3 kilonewton. Right? So the negative indicates that the direction what I have chosen is a wrong direction. That's it. Which means my force here it is not upward direction. My force here is in downward direction. Right? So no need to worry. So whatever it is, no need to worry about it. You can directly write what is your answer. That's enough. Right? So minus 14.3 kilometer. Okay, don't change the direction what I have done here. Let me consider this one. So a little bit complicated. So you can able to see there are lots of forces here. Right? They're asking you to identify what is the reaction at A. So A is this point. Right? A is this point. I have to identify what is the reaction at A. So let me name this first. So let me call this as A, this as B, C, D. This point is E. E is at the center, that is at 1 meter. Okay. F and G. These are my overall values. Right. So the first thing is, so whenever you have a complicated problem, something like this, right? So don't get frightened about these things, right? So what you do is you convert everything to a point load. You convert whenever you have an inclined force to a horizontal and vertical force, right? So that will do whatever it is. So that will make you easy, right? Okay, so what I'm going to do, I'm going to convert everything here. So let me put a rectangle here. Right? So this is my point A, or fixed point. Point B doesn't matter, it's directly applicable, which is 10 kilonewton. I'll directly test 10 kilonewton. And the distance is 2 meters. This is my point B. Point C is here. But I'm going to create one more point. Right? E, F, G, H. I'm going to create one point which is H. Reason? Converting this UDL to a point load. When I convert this, what happens? So 5 kilonewton per meter. It is for 6 meters. So 5 into 6, that is my total value. That will be acting at the center, which is at 3 meter and 3 meter. Okay, so which means H is 3 meter, C to H is 3 meter. So this is also 3, B to C is also 3, which is given. So C to H is 3 meter. At H, you have one vertical force, right? What is that vertical force? It is 30 kilonewton. How you get this 30? So 5 into 6, right? That is your 30 kilonewton. Next, you have D. There is also 3 meter. Okay. Then E. So E is here. So it has a moment. No need to worry about it, which is 50 kilonewton meter. Okay. Next, you have F. You have F, which is here. Note D to F is 2. D to F is 2. Right. So this distance is 2. It is not from E to F. Okay, don't get confused. So from F and G, I'm going to create one more point, I. I'm going to create one more point, I. Because I'm going to convert this UVL, is a uniformly varying load. I'm going to convert this to a point load, right? So what is the procedure for converting that? So if this is your uniformly varying load, it's a triangle, right? So if this is W, height is W and your breadth is L. So when you convert it, what you'll get? You will have W into L divided by 2, half into base into height, area of the triangle. Where it will be acting at from the apex. This is my apex. From here it is 2/3. of L. From the base, it is 1/3. So L by 3. Right? Same concept I'm going to use here. In that case, from F to I, it is 2/3. So 2 by 3 into 3. So 2 by 3 into 3 is nothing but 2. So this is 2 meter. I and G, it is L by 3. So L is 3. So 3 by 3, it is 1. Here you have that load. So where it is acting downward. So sorry, towards upward like this. Right? What is the value of this? 6 into 3 divided by 2. Right? So W into L divided by 2. So 6 into 3 is 18. 18 by 2 is 9. So this is 9 kilometers. Any doubt in this?
Sir, 90 தான் சார் வரும்.
Yeah, 90.
30 kilonewton தான் சார்.
இல்ல அது வேற. அது வந்து இந்த தனியா ஒரு இன்க்ளைன்டு ஃபோர்ஸ் இருக்கு. அதுதான் 30.
ஓகே சார்.
கிலோ நியூட்டன் பர் மீட்டர்னு இருக்கான்னு பாருங்க. 6 kilo Newton per meter. இதுதான் எடுத்துக்கணும். Right? This one and this one. UDL. UVL. Uniform Varying Load. Right? So 6 into 3, 18 divided by 2. Right? So that is my this force. Last, I have inclined force. Let me resolve this. When I resolve it, I'll get 2. One is like this. Other one's like this. Sorry. Other one's like this. Okay. So when I resolve this, what happened? One will be on x-axis, negative x-axis. Other will be negative y-axis. Because this is in which quadrant? If I put a plus here, it is in third quadrant. Third quadrant, both are negative. So I have to indicate it like this. So resolve this. So 30 sine 20 and 30 cos 20. That are the two values you will get, right? So this will be 30 sine 20. And this will be 30 cos 20. Now, see, I have highlighted all my distances. I am highlighting all my distances. Okay, and all my forces are also, it is indicated, right, in different colors. So once you have done this, then the part is over. Then we can easily solve this problem, right? Okay, you have a fixed support. When you have a fixed support, you know that you will have AX, you have AY, and you also have moment reaction, ME. All are applicable. Okay, right. So what I can do, I can say sigma fx is equal to 0. Let me put sigma fx is equal to 0. When I do that, what will get? Ax, one x-axis force, then there is no other x-axis, only this one, minus 30 cos 20. So minus 30 cos 20. This is equal to 0. So what will get? What is your Ax then? So 28.19 kilonewton. So that's completes this part. Okay. Next, equate sigma fy is equal to 0. Sigma fy is equal to 0. So this is not the order. Fx தான் பண்ணணும், fy தான் பண்ணணும்லாம் கிடையாது. It is up to you. மொமெண்ட்டும் ஃபர்ஸ்ட் பண்ணலாம், எப்படி வேணா பண்ணலாம். பட் இந்த மூணு ஈக்குவேஷன் நீங்க பண்ணணும் அவ்வளவுதான். ரைட்? ஸோ டோன்ட் நீட் டு வரி. ஸோ இது மாத்துறதுனால ப்ரொசீஜர் மாறுமானலாம் கிடையாது. டசன்ட் மேட்டர். Right? You will get the same thing. Okay. So if I consider sigma fy is equal to 0, what are my forces? Right? So you have Ay, vertical forces. Ay, upward force, positive. 10 downward, minus 10. Again, this one, another force, minus 30. This is moment. You should not add it. Right? So this one, plus 9 and this one. So minus 30 sin 20. Right? So no other force. That's it. So this is equal to 0. So can you identify what is my AY now? 41.26 kilonewton. Right? So this part is also over. Now we'll proceed with moment. When we take moment at any point is equal to 0. I'm going to take moment at A and A is going to equal to 0. Right? So I'm taking moment at point A. Right? So I'm taking that moment at point A and I'm going to equate it. Okay. So in the beginning itself, I told that it is equal to 0. Right? In this, whatever I do, it will be equal to 0 only. Right? Just for understanding purpose, I'm doing this. In your real examination, you don't need to do this because you know that moment at this point is 0. Whatever you multiply, there is nothing to identify. Right? So I can identify what is moment at A. That's it. Okay. So to identify what is the reaction, here I can identify what is the moment at A. That's it. Okay. Right. So to identify this, so let me consider from point here. Point here, you have one clockwise reaction moment, so which is MA. So this is different. This is different. This is reaction moment. So MA minus MA. Next, 10 into 2. So force into perpendicular distance, right? So distance is 2 meter from A. So 10 into 2 force into perpendicular distance. Rotation clockwise. So minus 10 into 2. Next, this 30. So minus, again, that is also rotating clockwise. 30 into distance. So 30 from A, what is the distance? 3 plus 3 plus 2. Right? Totally 8. Right? So 30 into 8. So it is 30 into 8. Clockwise rotation. Already a direct moment here. So directly I can write it out, which is minus 50. Right? Because it is rotating in clockwise. Now let me go for 9. So 9 is rotating in anti-clockwise. 9 is rotating in anti-clockwise. So plus 9 into distance. What is the distance of 9 from A? So 2, 2 plus 2, 4, 4 plus 3, 7, 10, 11, 12, 13, 14, 15. So 9 into 15. Right? So this is my moment. Next, last one, 30. Rotation is clockwise. So minus 30 sine 20. That is my force. Distance is 15 plus 1, 60. Distance is 1 plus 2 plus 2 plus 3 plus 3 plus 3 plus 2. Right? What about this force? Does it have distance? 30 cos 20. Do you have any distance for this? No, there is no distance. So that is 0. So only this is, I can equate it to 0. So can you identify what is your MA?
Sir, minus 339.16.
Okay, minus 339.16 kilonewton meter. Okay. So the negative indicates that whatever the direction I am assumed is wrong, which means my direction should be in anti-clockwise direction. Okay, that's it. We consider this one, right? So you have two beams, so one over the other, right? So in that case, you have to identify what is your reactions at A, B, C, and D in all the points. Okay, right. So for this, I have to draw two free body diagrams. One for the beam AB, other one for the beam CD. Right? Let me do one by one. First, for beam AB, we draw what is the free body diagram for AB. Right? So this is my point A. This is my point B. Right? So A location is having a hinge support. Hinge support will have two reactions, which means you'll have AX and AY. Right? Next, you have a point load here. You have a point load here. It's an inclined force, which means I can resolve it, right? So I can make this as vertical. So vertical will be sine. So 30 sine 60. Other one is horizontal, which is 30 cos 60. Right? I think 30 cos 60 is 15. I will directly write down. This is 15. Next, you have C point here. C is a roller support, which means I have a CY reaction here. Since it is having contact, you have a reaction CY. B is also a roller support. You have one more reaction here, which is B. Any doubt?
No, sir.
Right? So this is the free body diagram for B. So AB beams, AB beam. Next, I go for CD beam. Right? If I go for CD, so I have something like this. So this is my location C. This is my location D. So C is having a roller support, which means I have CY. Same CY as here. D is a hinge support, which have two reactions, which is dy and dx. Right? dy and dx. Okay. Now you have a UDL, uniformly distributed load. So for reference, I am drawing that first. So my uniformly distributed load is like this here. Right? It is 10 kilonewton per meter. So look at the distance. So this is 3 meter. This is 2 meter. After that, again, we have another 2 meters. Okay. So I can convert this to a point load. So what I can do, I can make this as a point load. So we have one point load at the center, which is 10 into 2. So 20 kilonewton. Where will be acting at the center of this two, which means 1 meter here and 1 meter here. Okay. Now I have drawn the free body diagram for both cases, right? For beam AB and the CD. So the first one, which one we have to solve first? AB beam or CD beam?
CD, sir.
CD, very good. The reason is the whatever which is having minimum unknowns, that has to be solved first. When you look here, so 1, 2, 3, 4 unknowns. It has 4 unknowns here in this particular beam. Whereas here you have only 3 unknowns, right? So the best way is to solve this one first. Then you have to proceed with the other one. Okay, right. So let me solve this one. Right. So now I will eliminate this one. I don't want this UDL. Instead of this UDL, I have converted it 20 kilonewton for 1 meter and 1 meter. Yeah. So let me solve this. So let me say that sigma fx is equal to 0 for this part. There is no horizontal force, only one, which means I can say that dx is equal to 0. Right? Next, sigma fy is equal to 0. And I equate it. Right? So cy plus dy minus 20 is equal to 0. This means I can write that cy plus dy is equal to 20. This is equation number 1. Any doubt on this?
No, sir.
Next, moment. I'll take moment at C or moment at D equal to 0. I'll take C, right? If I take moment at C is equal to 0, Cy will become 0, leave it. So 20. So 20 into distance is 4 meter, right? Rotation is clockwise. So minus 20 into 4, right? Minus 20 into 4. This dy. So plus, that is in anti-clockwise, plus dy into, so 2 plus 1 plus 1 plus 3. So 5, 6, 7 is equal to 0, right? Because dx doesn't have distance, that is 0 already. So what is your dy?
11.4, sir.
Yeah, it is 11.4 kilonewton, right? Substitute it in this equation. Substitute in this equation, find out what is your C1. What is your C1?
8.6, sir.
So it is 8.6 kilonewton. Yeah. So now I completed this part, right? The next thing is I'll go for the next free body diagram. So this is my next free body diagram. Let me take this particular beam, right? So now I got one value, which is C1. I can directly substitute that, which is 8.6 kilonewton, right? Same procedure, we'll follow the same one. So let me say that sigma fx is equal to 0. And I put sigma fx 0 is 0. What is it? Ax minus 15 is equal to 0, right? So only just two forces, which means I can say that Ax is equal to 15 kilonewton, right? That's okay. Next, sigma Fy is equal to 0. Fy minus 30 into sine 60, this one, minus 8.6, this one, plus By is equal to 0, which means I will get Ay plus By is equal to the value of these things. So what is the value here?
34.58.
So you're getting 34.58. So let me consider this as equation 2. Right? So this part is also over. Next, I'm going to take moment. So let me take moment at A and I will go to equate it to 0. So 30 sine 60 into 2. Force into perpendicular distance. Rotation is clockwise. So minus 30 into sine 60 into 2. Right? 15 doesn't have distance. Distance is 0. So I'll leave this. Next, 8.6 into 4. Right? So minus 8.6 into 4. Right? 8.6 into 4. Next, by. That is anti-clockwise. So by into total distance 5 plus 2. So 7. So plus by into 7. This is equal to 0. So let's identify what is your by. What's your by?
12.33, sir.
12.33, sir.
Yeah. So 12.33 kilonewton. Yeah, very good. So now you substitute in equation 2 and find out what is the A1. So 22.25 kilonewton. That's it. Any doubt on this?
No, sir.